we are going to concentrate on how to calculate for mode in a grouped frequency table, or performing analysis on mode in a grouped frequency table. Now, for a grouped frequency table, calculating for mode goes through different principles. And in this video, we are systematically going to take you through those principles. So pay attention. Now, for a grouped frequency table, first of all, how would you even identify that the table you are working with is a grouped frequency table? You always have to observe the variable column. So, and I mentioned earlier on that the variable column is usually the first column. Okay, so over here, there's a variable column, and this one is a frequency column. So now, how are you going to know it's a grouped frequency table? The variable column, you are going to observe classes over there or intervals over there in the variable column. So see here, 12, 15, 16 to 19, 20 to 23, 24 to 27, 28 to 31. So you see the variable column is in classes and ranges. So that tells you this is a grouped frequency table, and we are going to work out for the mode. Now, how to get the mode in group frequency is completely different from that, even though some of the concepts you learned over there would help you in understanding how to calculate for mode in a group frequency table. Now, let's go. The first thing that you do when you are given a frequency table like this, a group frequency table like this, to calculate for the mode is that try and identify the modal class. That's the first thing that you are going to do. Okay, the modal class simply means that observe the classes and their corresponding frequencies and identify the class with the highest frequency. So you pay attention and observe. You always have to be patient and make sure you've observed all the classes. Is that okay? Because sometimes a particular class with a high frequency would catch your attention and you may not observe down. It may be there is another one down there which is higher than the one that caught your attention. So you have to take your time, be patient, and observe all the classes. So here, the first class is 6, the second class is 10, the third class is 18, the fourth class is 9, and then the last class is 7. So now, clearly from the various classes, you can see the number of patients. The highest frequency here is 18. So it means the modal class is what? Is 20 to 23. So I mentioned that the first thing to do when you are calculating for mode in a group frequency table is to identify the modal class. And over here, you have to observe all the frequencies. Now, the highest frequency is 18, and that means that the modal class is 20 to 23. How do you identify the modal class for the last time? Observe the highest frequency. The highest frequency is 18, and that corresponds to the class 20 to 23, meaning the modal class is 20 to 23. Then you write it down. So the modal class is 20 to 23. Now, after stating the modal class, then now you state the formula for mode in a group frequency table. Now, let's even look at the questions that we've been asked to solve. The question says that this is showing the respiratory rate of patients that were admitted to a particular hospital ward. 50 patients that were admitted to a particular hospital ward. Now, the question states that identify the modal class, and that is what we've done. Okay, the second question says, using the mode formula for group frequency, calculate the modal respiratory rate. Okay, now let's state the formula for mode in a group frequency table. Now, the formula for mode in a group frequency table, we have Lm plus into brackets F1 minus F0 all over 2 F1 minus F0 minus F2 close the bracket times H. So this is the formula for mode in a group frequency table. Now let's look at the interpretation of the formula. In statistics, usually when you state the formula, it's not enough. you should be able to interpret the formula and identify the various elements within the formula. Now, this LM represents the lower boundary of the modal class. The lower boundary of the modal class. Now let's look at the F1. The F1 represents frequency of the modal class. The F0 represents frequency of the class before the modal class. Then we have F2. F2 represents frequency of the class after the modal class. And then our H represent the class width of the modal class. Class width or class size of the modal class. All right, so we have, so this is the formula. So the formula for mode in a group frequency table, the formula LM, which is the lower class boundary of the modal class, plus the frequency of the modal class minus frequency of the class before the modal class, all over 2 times frequency of the modal class minus frequency of the class before the modal class minus frequency of the class after the modal class. Close the bracket for all multiplied by H, which is the class width. So now we are going back to the table. The lower boundary of the modal class. Now the question is, where is the modal class? 20 to 23. Here is it. The modal class is the class with the highest frequency. Here. So this is the highest frequency. The modal class that corresponds to that is this. Now LM says the lower boundary of the modal class. Now this is the lower limit of the modal class. So the lower boundary subtracts 0.5. So we are going to get 19.5 over here. So the lower boundary of the modal class is 19.5. Okay? Now, F1, frequency of the modal class. Let's come back to the table. What is the frequency of the modal class? 18. And you can write the 18 over here against the interpretation. Now, F0 says frequency of the class before the modal class. What is the class before the modal class? This is the class before the modal class. The F0 is the frequency of the class before the modal class. And that is what? 10. Then you come and write that 10 against this. Now, the next one is F2. Frequency of the class after the modal class. Now, what is the class after the modal class? 24 to 20. 24 to 27. And then the frequency that corresponds to that is 9. The frequency that corresponds to that is 9. Then you come and write the 9 over here. So frequency of the class after the modal class, that is 9. The H is the class width or size of the modal class. The class width or size of the modal class. Now let's come to the modal class. That is 20 to 23. Now 20 to 23, how do we calculate for class size? We have 2 approaches that you can use. Class size is equal to upper limit minus lower limit plus 1, or upper boundary minus lower boundary. Now, the reason why, if you are using the limits, you always have to add plus 1. The reason is because the limits would always omit one discrete value in the interval. So in statistics, when you are using the limit to calculate the class size, you have to factor in an additional one discrete value. But if you are using the boundary is always going to factor all the discrete values within the interval. So for example, if you have 2 to 4, and you want to calculate for the class boundary, this is the limit, this is the lower limit, and this is the upper. If you want to use this to calculate for the class size, the formula is going to be 4 minus 2. That will give you 2. But let's check this one. In between 2 and 4, we have 2, 3, and then 4. So 1, 2, 3. So the interval, the size is not actually 2. The size is actually 3. So if you are using the limit, you always have to add plus 1. But if you are using the boundary, this one, it will be 1.5. This one will be 4.5. 4.5 minus 1.5. That will give us 3. Is that okay? Yes. So always in statistics, it's good you always use the boundary. So how do we get our class size? Our class size is going to be 23.5 minus 19.5. Yet, where did we get it from? From here. The lower limit is 20. You subtract 0.5 from it. The upper limit is 23. You add 0.5. So you are going to get 23.5 minus 19.5. And that is what we've done over here. And that will give us, yes, put that on the calculator. That will give us 4. Then you put that 4 over here. Are you sure it will give us 4? Yes, you put that 4 over here. Okay, so our class size or class width, the modal class. Yes, so now we have all the elements that we need to calculate for the mode. So we will just interpolate all of them into the formula. So now let's interpolate all of them back into the formula. So the mode is equal to, the LM is equal to 19.5. Plus F1 is equal to 18. That's the frequency of the modal class. That is 18. Minus F0 is frequency of the class before the modal class. That is 10. All over 2 times frequency of the modal class. That is 18. So 2 times 18. Minus frequency of the class before the modal class. Where is it? That is 10. Frequency of the class before the modal class. That is 10. Minus frequency of the class after the modal class. That is 9. Then you close the bracket. Then you multiply by h. H is equal to 4. H is 4. How did we get the h? You convert this one to boundary to become 19.5. You convert this one to boundary to become 23.5. So 23.5 minus 19.5. And that's how come we had the 4 over here. I asked you to confirm whether it's 4. Okay, that is fine. So now, when you get to this side of the calculation, it's always very important to simplify the one in the bracket first. Yes, it's always very important to simplify the one in the bracket first, systematically. So 18 minus 10 will give us, 8. All over 2 times 18 will give us 36. Minus 10, 26. Minus 9, 17. So it's always very important to simplify it this way. Make it very simple first, especially the one in the bracket first, before you proceed to simplify it to your final answer. So now we are going to have, let's do, we can even do, we have, what we can do, let's simplify this one first. 18 divided by 17 and multiply it by 4. What do you get? 1 point. So 18 divided by 17 multiplied by 4. So 19.5 plus 1.882. Good. Then add it to the 19.5. 21.38. So our mode is equal to 21.4. Then you add the units, breath per minute. All right. So let me go over this for the last time. Now, when we give you a group frequency table, no, breath per minute. So always stick to the units that has been given to you in there. No, yes. So here, usually for mode, don't always rush to convert it to a single unit. Yes. Don't always rush to convert it to a single unit. So for mode, if you get it this way, it's fine. But anyway, mode is also a discrete value. So if you want to convert it, and then, for example, mode is not always a discrete value. Looking at the variable or the data we are looking at, is it discrete? It's a discrete value, so you can convert it into. It's fine. All right, so let's go over it for the last time. So we have a table showing respiratory rate of 50 patients over here. Okay, now for the 50 patients, let's check the variable column. We have respiratory rate in breath per minute, and then we have number of patients. I mentioned earlier on that if we give you a table, how do you identify as a group frequency table? You check the variable column. And usually the variable column is the first column. Then we have the second column, which usually is the frequency column. So here we have the variable column over here. Now, in calculating for mode in a group frequency table, always check the frequencies and first of all, identify your modal class. What's the meaning of modal class? The class with the highest frequency. So we have the classes here. We have the first class, the second class, the third class, the fourth class, the fifth class. Now check the frequencies. What's the highest frequency? 18. Which class does it correspond to? 20 to 23. Meaning the modal class is 20 to 23. Then you write it down. Modal class is equal to 20 to 23. Then now you come and state the formula for calculating mode in group frequency table. What is the formula? The formula for mode in group frequency table is Lm plus into brackets F1 minus F0 all over 2F1 minus F0 minus F2, close the bracket, multiplied by H. Now, the Lm represents the lower boundary of the modal class. The F1 represents the frequency of the modal class. The F0 represents the frequency of the class before the modal class. Then 2F1 minus F0 minus F2. This F2 represents frequency of the class after the modal class. Is that okay? So now, after stating the formula, then we have multiplied by H. The H is the class size or the class width. And I mentioned that in calculating the H, always use the class boundary. If you decide to use the class limits, you have to add +1 to your calculation. Okay, good. So now you look for the lower boundary. How did we get the lower boundary of the modal class? So it says that the lower boundary of the modal class. So what is the modal class? 20 to 23. The lower boundary is this. The lower boundary, so the lower limit is 20. If you want to get a boundary, it's 20 minus 0.5. And that will give us 19.5. Okay? Then you write the 19.5 there. Now the F1 is frequency of the modal class. Come back to the modal class again. The frequency of the modal class is 18. Then you write the 18 down. F0, frequency of the class before the modal class. The class before the modal class is 16 to 19. The frequency is 10. F2, frequency of the class after the modal class. The class after the modal class is 24 to 27. And then the frequency is 9. You write it there, 9. The H is the class size or class width of the modal class. Then you come and check the class size. And I told you the class size is equal to the upper boundary minus the lower boundary. In this situation, the class size was 4. How did we get that? It will be 23.5 minus 19.5. And then we had the 4 over there. Now, after getting all these elements, you just interpolate them into the formula. So the mode is equal to, the LM is 19.5 plus 18 minus 10 all over 2 times 18 minus 10 minus 9. Then you multiply it by 4. So here, the mode is equal to 19.5 plus into bracket. And I mentioned that in a calculation like this, always simplify the one in the bracket first. Try and break it down before you proceed with the other calculations. So we are going to get 18 over 17, then you multiply it by 4. You do the multiplication first because board mass will apply over here. Bracket of multiplication. So board mass concept applies over here. Is that okay? Great. So you simplify these parts. So 18 over 7 times 4 first before you come and add it to the 19.5. If you perform the calculation very well, you end up getting 21.38. Okay, so like we discussed, respiratory rate is a discrete data. We have 21.4. If you want to, but you can leave the answer over here, 21.4. But remember to add the units. Okay, so this becomes our mode. Is that okay? Great. All right. Thank you.
All right, so this is our last question on the grouped frequency table, how to calculate for mode on the group frequency table. So this table actually presents 40 patients who went for screening, okay, BMI screening, okay. So with this question, what we have to do is that we have to first confirm whether it's a group data. So of which, if you look at it, it is a group frequency table because of this one. You see that it has been grouped, okay. So after you have confirmed, so this is the variable column and this is the frequency. So now what you have to do is that you have to first identify your modal class, okay. And in identifying your modal class, you have to look at the highest frequency here, then use that one. So over here, 13 is the highest frequency. So therefore, the modal class is what? So analysis. So our modal class is what? So the modal class is what? 22 to 24. Okay. So of which it answers the question number 1. So now the next thing is that the question says that using the formula for group frequency table, we have to calculate for the mode. So with this one, we use the formula, and this is the formula. Mode is equal to LM plus okay. So this is the formula. So this one, where the LM is our lower class boundary, okay, of the modal class, okay. And then the F1 is our frequency of the modal class, okay. Then F0 is the frequency of the frequency before the modal class, okay. So frequency of the class before the modal class, okay. Then so I've explained the F1. The F2 is the frequency of the class after the modal class, okay. So we know that this is our modal class. Do you get it? So now another person too can do a table and include the class boundary so that it becomes easy for the person. But notwithstanding, for you to get a class boundary, you want this one minus this divided by 2, which is what? 0.5. So that's 0.5. You subtract it from this one, you add it. So let's quickly let's add the class boundary to it and see. So with that one, we have here to be what? 15.5 to 18.5. Then here becomes 18.5 to 21.5. Always this and this become the same thing. So here will be 21.5 to 24.5. Then here is 24.5 to 27.5. And this is what? 27.5 to 28 to 30.5. So now with so let's first write our parameters. So in writing our parameters, we can say that the Rm is what? It's talking about the lower class boundary of the modal class, and this is our modal class. So this is the lower class boundary, which is what? 21.5. Okay, then we have our F1. So the F1 is the frequency of what? Of the modal class, and the frequency of the modal class is what? 13. Then F0 is the frequency before the modal class. So if you look at it, this is the modal class. So the frequency before it is what? Is what? Is 8. And then our F2 is frequency after the modal class, after the modal class frequency. Okay. So that one will be what? 9. So now we can put everything in the formula. So we have, okay, now the H. So the H is the class width, okay, or the class size. So with that one, to calculate it, we have to see this one is the, so we have to just what? Subtract this from this, okay. So that's going to be 24.5 minus 21.5, and that's going to give us what? That's going to give us what? 3. 4 or 3. So calculate this. So that's going to give us 3. Okay. So here becomes what? 3. So in putting it into the formula, we will have what? Mode to be 21.5 plus, we have this one to be what? 13 minus 8 2. Our F1 is what? 13 minus what? F0, which is what? 8 minus F2, which is what? 9 times what? 3. Okay, so BODMAS have to be applied over here. So because of BODMAS, so we have to still repeat this one. Then we add everything in the bracket. So in adding everything in the bracket, please, what are you getting? Yes, add everything in the bracket. 30 minus this over. So this one is going to be 5. Anyway, if you want to calculate it slowly, so this one will be what? 6. Okay. So multiply it automatically. This one here is 2. So what are you going to get? It's 9. Okay. So now, if you want to use mathematics, we would have said that, okay, now you have to multiply. So just multiply and let's see. 9 over 5, 5 over 9 times 3. That one is going to give it, which, 5 over 9 times 3 will be what? 1.7. Okay, so now add the 2. So in adding the 2, what are you going to get? Are you sure? 23.2. Is that what you are getting? Yes. Okay. So BMI, is it a discrete or continuous? It's a continuous. So that means that we can maintain the answer like that. Okay. All right. So that means that our mode is what? 23.2 what? And then the unit of BMI is what? Okay, kilogram per meter square. So this brings us to the answer for mode. Okay, so let's go over again. We said you first have to find what your modal class, and in finding the modal class, you have to look at the highest what frequency. So the highest frequency is what 13. So therefore, this becomes what our modal class. After we have gotten the modal class, we have to then find for, so we can add the class boundary to it. In adding the class boundary, okay, we said yes, subtract 18 from 19, you get 1 divided by 2, which is 0.5. You subtract it from this side and you add it to this. So it becomes what 15 point this, that, so like this. So now this one is talking about the lower class boundary of the modal class. So and this is the modal class, okay. So therefore it becomes what this 21.5. Then we say that the F1 is the frequency of the modal class, and frequency of the modal class is what 13. Then our F0 is what frequency before the modal class, which is what 8, okay. And then F2 is what frequency after the modal class, which is what 9. So you put that into the formula, then you solve everything, and you what arrive at 23.2 kilogram per meter square. So this will bring us to the end of what the grouped frequency table, how to calculate for the mode. Okay, bye.